Hello and welcome back to HVAC Tech Talk with Chad. Today we're going to be doing a combustion test on a Lennox 80% atmospheric vent furnace. So I'm using my UEI C127 Eagle combustion analyzing machine. I like using this along with my E-instruments and my Bacroc. Most of the time I'll bring both. I'll bring two different instruments to ensure that I have proper readings. But as you see, when you turn it on, the oxygen's at 20.9. That's the free oxygen in the air everywhere. So that's when you know your machine is calibrated. What I'm going to do right now is a temperature rise. On the inside of this panel, there's a metal plate where the manufacturer gives you all of the recommendations of where they want the parameters to be. On the temperature rise for this furnace, the temperature rises between 70 and 100 degrees. So I've hooked up my thermistors. I will turn my machine to temperature. It'll give me a T1 and a T2 and a delta T. So here's my thermistor for my supply. My return's already in. I've made my hole with this little poker, and I will put this up into the supply. The furnace has been running for a few minutes, so it's at steady state. And we want to be somewhere between 70 and 100 degrees on our temperature rise or our delta T. Right now we're at 74, 76. This is how you know whether you need to turn up the blower motor or leave it where it's at, or possibly turn it down. You don't want to be below 70 and you don't want to be above 100. Looks like it's settled out. I'll get my printer and I will print my temperature rise as part of my test. And here's my printer. This isn't one of the newer machines. In the last few years, they've come out with actual printers that print hard copies. This printer here needs to, this copy needs to be signed by the homeowner. We'll put the appliance model and serial and all the pertinent information on it. So the printer comes out and it tells us exactly what we wanted. It's February the 4th, 2016 at 12:08. 14 seconds p.m. Our delta T is 92.9. It's really right where we want it. Our supply air going out is 144.9 or 145 degrees, and our return is 52 degrees. So I will put in the customer's name, have them sign it. The appliance is a Lennox. I'll put the model and serial number here, and this will be part of our report that we give to the customer and that we put at our office for information. Thank you. We'll be doing a combustion analysis here in just a moment. Welcome back for that. Okay, welcome back. Earlier today we changed the gas valve and replaced the thermocouple and cleaned off the pilot draft hood in this Lennox furnace, 80% furnace. We've done our temperature rise test, and now we're getting ready to do our combustion analysis to see how it's burning. We already have a CO test porthole that's right here for our exhaust, and we're going to go ahead and poke a hole through there and make it a little bit bigger so that our probe can go inside. We know we're at the reading we need to be before we start our test. We're at 20.9 on our free oxygen. So we're going to go ahead and put the probe in and see what our readings come out to be. Okay? You see the temperature of the flue is going up into the 400s, which is really good. We want to be up at that area. We did some adjustments on this earlier to make sure everything was good. You want your furnace, an 80% furnace should be in the area of 400 or above on the flue temperature. 375 would, 350 to 375 is going to be your low end. So Let's see what we have. We've got, let me push my keeper on my probe in there a little more so it steadies it. Okay. So now I'm going to go ahead and do my printout on my test. As soon as it settles down some. Let it settle. We're beautiful on our temperature in our exhaust. So we're going to go ahead and print. So as you can see, it's printing out our results. We will put all of these results together. We'll put them on a sheet and give them to the homeowner in an envelope and keep them until next year when we come back and we do another cleaning in the winter. Results are finishing at this point. Now, one of the things I like to do while I do a combustion analysis is I like to test the supply going into the house, because I want to make sure that I don't have any carbon monoxide at all. If we have carbon monoxide in the supply plenum, then we have a cracked heat exchanger. It's one way to be sure that you don't have a cracked heat exchanger. So I'll go ahead and open my hole a little bit bigger for my probe. We will do a test on that to confirm. We'll come back to these results in a moment. Let me go ahead and put this in here. Let that go. These are the results of the combustion analysis. This tells us that on February the 4th, 2016 at 12:14 p.m. with natural gas, our oxygen was at 10.6. Our carbon dioxide, which is our fuel, is 5.9. Our carbon monoxide is 29 parts per million. Our NOx are 43 parts per million, and our flue temperature was 423.6. The flue temperature plays a very, very big role in the carbon monoxide parts per million. The lower your flue temperature is on a standard non-condensing appliance, the lower that flue temperature is, the higher your carbon dioxide is going to be. So our efficiency is 75.6 on a 20-year-old appliance. So that's our results. We'll put the customer's name in here, have them sign the results. We'll run copies and have some for our office and some for theirs. We'll put in the model and the serial number of the appliance there. Let's look now at what we have. We can see here that carbon monoxide we have absolutely zero. This is the supply air test. Our temperature in the supply is similar to the temperature of the supply air we had earlier. So we're going to go ahead and print this one also, and that is going to show that we don't have any carbon monoxide at all inside of the supply plenum. That is how you should do a combustion analysis to be sure that you're giving your customers the most proper and effective testing. Thank you for watching. Welcome back to HVAC Tech Talk with Chad Padilla. Today we're going to look at a thermocouple. What actually is the thermocouple? What is it made of, and how does it work? Here's the thermocouple here. This top portion up here, which is welded, is called the hot junction. Inside of this section on the inner area is a dissimilar metal, which is called the cold junction. When the hot junction is heated, as the manufacturer requests that you heat it in the first half inch, that is 1/2 inch right there. That's where the flame should hit, and then it creates millivolts through the dissimilar metals. You have your copper sleeve that comes around, and then you can see where you have a copper wire that is inside of the copper sleeve. It's called the inner wire lead. You have your attaching nut, you have a lock washer, and you have your tin-plated contact, which makes contact with the gas valve at this point. Now we're going to look at this because this is called the electromagnetic power unit. So I'm going to unscrew this, and pull this out, and we're going to look at the parts of this electromagnetic unit that allow the thermocouple to operate. Okay, we've removed the electromagnetic power unit, and here is our mainspring. Okay, our mainspring pushes against a lever on the interior. If you can see that, pushes a lever on the interior, which the lever sits in this position with a cup, rubber cup on the other end, and when it's pushed up, the cup holds the gas from flowing anywhere. When the spring is released and the magnets attract the keeper plate, it drops, allowing flow to the pilot tube. So let's look at that right now. So we're going to take off this section here, and we're going to look at the windings around these two steel posts. When the millivolts come through your thermocouple and they send the millivolts through here, they magnetize these two steel posts, which pulls in the mainspring, and this is what's called the keeper. The keeper gets attached to it. So it looks somewhat like that. I don't know if you can see it through that clear section, but it pulls that up, allows the gas to flow through the pilot. The pilot stays lit as long as it's producing a minimum of 20 millivolts. I mean, you can go down to 17, but if you're down below 20 millivolts, you need to either clean or replace your thermocouple. So what we're going to do is, earlier today, we changed the gas valve on this Lennox unit, and we're going to do a live millivolt check on our thermocouple. Okay? See you in a moment. Okay, earlier today I replaced the gas valve and the thermocouple on this Lennox 80% atmospheric furnace. So there's two wrenches that you're going to need when you're working with the pilot assembly. That is a 7/16 inch open end wrench. That fits the nut for that. The other is for the thermocouple. It's a 3/8 inch open end wrench. So I have the furnace running right now. I'm going to unplug it because I definitely don't want to be creating any kind of contacts in here while electricity is running. One of the things that I like to do whenever I'm working on any electrical appliance is I like to use my my Greeley voltage detector. This detects any volts around between 50 to 500. So I just turn it to on. I come here, I've got voltage. The other thing I like to do, because this is a house that's at least 20 years old, is I like to ensure that I have the correct continuity and inside my switch, or inside my plug in this instance. So I plug it in. If I have the red and the orange, it is correct. That's what it states. So now I know that I have the correct polarity inside of my switch. Many years ago, they weren't concerned with the polarity as much as they are now. So let me move into taking the furnace, turning it into the off position. So we're shut down, and I'm going to remove the thermocouple. Now, all you need to do is hand tighten it in a quarter turn. So I should not have to move this very much at all before I use my fingers to loosen it the rest of the way, okay? So there we are there, and then I'll be able to remove this from here. Pilot's out. And my thermocouple's out. So what I'm going to do here is I'm going to give myself room. I'm going to attach my voltage meter to my thermocouple. And to do that, I'm going to need a couple alligator clips. So I'm going to get my alligator clips out. Okay. I have a positive lead for my voltage meter. Put this in, and I will attach my positive lead to the copper sleeve, and I will take an alligator clip to the tin section, and I will attach that to my common lead. I will select millivolts on my machine. You can see the millivolt signal there, the small m with a large V, or the DC voltage is a straight line with 3 dashes underneath it, okay? So I'm going to need to light this pilot, and we'll do a reading in just a moment. Here we go. We're hooked up correctly. We're at 37.5, 37.8. I mean, we have a really strong reading on our thermocouple. Again, just relax while you're watching this, because at the end of this, we're going to pan into some papers that I've drawn up everything and explained all of this to you. But again, there is, I've heard that there's a difference in polarity if you hook up the red, your positive lead and your common lead, but I've tested both ways. Just make sure that one of the leads goes to the copper sleeve and the other one goes to your tin-plated connector, and you will get your reading. Okay, we've done our pilot test. We know that we've achieved the millivolts that we want to have, so I'm going to go ahead and let go. The pilot will turn off. I will turn this to the off position. It's in the off position now. I will remove my leads. Okay, while I'm working on the furnace, we've checked for correct continuity, and we've checked to see that we do have voltage there. I just want to do a test to see what voltage I do have. I've set my my meter on voltage. It's a kind of a swirly line with a V. So I'm going to go ahead and plug this in and make sure that I've got 119.9 volts, 119.8. So I'm right in where I want to go. So then I want to check my ground. I want to check my neutral to ground to make sure I don't have anything. I don't. Then I want to check my line voltage to ground. I have 100 line voltage to ground. I have the same reading that I had earlier. I have 119.9. You can see I have 119.9. Now I'm going to check my ground to ground. I should have 0 there. And no voltage. Okay? Okay, let me show you some of the safeties in this furnace before we leave. Right here on the side, which actually makes contact in here, is my vent safety. Then out of the vent safety comes to my, what I would call the heat exchanger thermostat. This has 2 settings on it, setting at 200 and a setting at 160. That means that when the heat exchanger reaches 200, the fan motor kicks on, and when the thermostat has met temperature, the fan continues to run, and when it comes down to 160, it shuts off. From here, we run down to our flame rollout switch. This is a one-time fuse rollout switch. If the flame does roll out from the heat exchanger, it's looking for oxygen. In order to create combustion and to keep combustion, you need 3 things. You need a fuel source. We have that. We have an ignition source. We have our pilot lit with the thermocouple keeping it lit, and then you need oxygen. So if you ever have to replace this switch, you know that you have a problem with either your combustion air not getting into this area here and into the burner chamber through the grills, or there's something blocked in the vent which is keeping it from creating combustion. The last thing that we have is we have an over temperature switch in the heat exchanger, which is these black wires that go to the ECO, which is the energy cutout. On this gas valve and on this furnace, they have an energy cutout. So if you ever do come across those, you must connect them up or jump them in order to get the furnace to turn on. This is a universal gas furnace that we're using, that we're putting in, and it replaces all of these different gas valves. It's a universal standing pilot gas valve that can also be used for millivolt. So now I'm going to go ahead and relight the pilot, plug it in, and let it kick back on. While we're here, I wanted to tell you that this screw right here, when you unscrew it, that's where you adjust the gas pressure, okay, in order to do your manifold test port right here. But that's where, when you're doing your combustion test, if you need to increase your CO2, you need to turn down on the spring in that area. This screw right here is your pilot adjustment. If your pilot isn't high enough and isn't strong enough onto the thermocouple, you would unscrew this, and then you would take in and you put your screwdriver and you turn counterclockwise for the pilot. Clockwise for more pressure because we have a spring on the regulator of the gas valve, and counterclockwise for more pilot fuel going through the pilot. Okay, the last step that I do when I'm doing a furnace overhaul or a furnace inspection is I come to the thermostat. This is a digital thermostat that has batteries. So I want to make sure that the batteries are good and they have a strong life left. If they don't, I want to replace them, okay? So I come over here and I take my voltage meter, put it on millivolts. That's going to be the DC volts with the straight line with the 3 dashes underneath it, and it'll have a small M and a large V. So I'll take my batteries and I'll put my common on the flat side and my positive on the other side, and it shows me I have 1 point. It's jumping all over the place. Let's see here. I have 1.471 millivolts. So I'm almost at full life on that battery. And now on this battery, let's check what's in here. I have 1.471. So almost have full life on both batteries. You can see on the side it shows 1.5 volts. So they don't need new batteries. Should last them at least 8 months or so. Thank you for coming to Heating Tech Talk with Chad. We appreciate you guys' viewing. Like I tell my golf buddies, fairways and greens, pals. Everything else will take care of itself. Have a great day.